Now, to understand what the idea behind keys is and when we need keys, let's come back to this concept of widget and element trees. Because you learned that every widget gets its element. That's what we covered in the last lectures. Now, what happens to those elements if two widgets change their place, as we're doing it in this to-do app? There, when we reorder our widgets, these widgets change their place. They're not staying in the same position. So what happens to those elements if those widgets change their place? Well, the element skeleton actually stays the same. We keep the same element structure, and indeed Flutter does not create new elements here. Instead, it only updates which element refers to which widget. And Flutter does this for performance reasons. It simply sees that even though something changed related to the widgets, it's still the same amount of widgets and the same type of widgets. Because here in this list, when we reorder our to-dos, we might be changing the order of some to-do items, but we still have the same amount of to-do items, and we also still have the same kind of widget. We have 3 to-do items, even though their text might have changed position. But for that reason, to optimize performance, Flutter does indeed not throw away those existing to-do item elements and recreate them, but instead it reuses them, but it keeps track of which element refers to which widget, to make sure that in the end the content that might be displayed inside of a widget, so the icon widget and the text widget that is responsible for outputting the to-do item specific data, that those things can be updated on the screen. To make sure that this is possible, Flutter connects every element to a widget, and therefore here it reuses the elements but updates the references. So that therefore the nested elements that were created for these to-do items, so in this case here, the element for the icon widget, the element for the sized box widget, and the element for the text widget can be updated to reflect the correct to-do item data. That is in the end what happens in this case here, where some to-dos might be shuffled around. Now, why is this important to understand? Because here it explains what happens behind the scenes, and as you can see here, the app works absolutely correctly and displays the intended result, despite Flutter reusing those elements. So we have the best of both worlds, we have good performance and display the intended result. But things start to break, at least without keys, if we make one important change inside of key start. If we replace to-do item, which is coming from the to-do item Dart file, with the checkable to-do item widget here, by using checkable to-do item and updating the imports to import checkable to-do item and get rid of this import, if we do that and we restart the app, we see that we now can mark these to-dos as completed, but what you will notice is that if I only check the first one here, and I then change the order, that looks broken. The first to-do is still checked, but of course this technically is now a different to-do. So now here we have a problem. Because even though Flutter does indeed manage element references, so references to widgets, and even though it updates those references, state is managed in a different way. And here we are dealing with state because in the checkable to-do widget, we indeed have a stateful widget, and there we are managing this checked state in the end. And we're getting this broken result here because the state objects that belong to widgets are managed as independent objects that are connected to the elements. And this actually makes sense because we also do have separate state classes. So indeed, we also get separate objects in memory. And before in the course, I mentioned that those state objects would be connected to the widget objects. Well, technically, that's not entirely correct. Instead, those state objects are connected to the element objects that are connected to the widgets. Now, if widgets change their place, as mentioned, Flutter reuses elements and just updates the references, the pointers to widgets, but the state objects don't move around. So here you can see that when to-do item A and B change the place, the states A and B stay in their places. And that now suddenly connects the to-do item B with the state A here, because the state don't move together with the widgets. Instead, they are connected to the elements, which also didn't move around, but which instead were reused and stayed in place and just got their widget references updated. And that's of course a problem, but it is a problem that is solved with help of keys.